Okay, so let's continue with the example 16, part C, D and E that includes the three-dimensional cases to decide a pair of lines, whether are they parallel, intersect, or skew. Okay, so these are all the 3D cases. So you might have a few different results, either parallel, either intersect, either skew, or they can be the same line as well. Okay, so now let's start. So this one they write in the IJK form. So I told you before, right? For me, I personally prefer to write in the column vector form. Okay, so for me, I will try to write out the P. So what is the P here? The direction of the line should be this one. So 3, -2, and also 4. And then what is the Q? So for the Q, it should be -6, 4, and also -8. So for the Q, I realized that I can actually try to factorize it. So to factorize it, I can take out a -2. So when I take out -2, I'm having 3, and then -2, and also 4. Then you double check and see, alright? So P and also Q are the multiple for each other, right? So you can write a simple summary first. P is a multiple of Q. Alright, so that means it go to the either the parallel side or either go to the same line side already on the left of the diagram, right? Okay, so after you decide that it is a multiple of Q, then the second criteria is you need to double check and see whether they belongs to the same line. So you take A, passing point A minus B. So what is the passing point A? So passing point A, I'm having 1, 1, 2, okay, minus the passing point B, which is 2, -1, and also 3. So if I minus it, and then I will have -1, 2, and also -1. So you double check and see, very obvious, this is not a multiple of P or Q. Okay, so as a conclusion, you can just write R1 and R2 are parallel. So when they are parallel to each other, you actually cannot find out the angle between them. There is no angle between them. There's also no intersection point between them. So this is how and where we should stop. That's it. Okay, so maybe for this one, you can also write out a short summary. A minus B is not a multiple of P or Q. So that's why the conclusion is R1 and R2 are parallel only to each other. Okay, so this is a simple 3D case. Right, okay, so no problem. Let's continue to discuss example D. Okay, so I hope that you roughly have the idea already about the table, the diagram that I show you. What are the criteria that we need to go through? Okay, all right, so for part D, so again, I want to check and see whether are they parallel, intersect, or skewed case. So I will need to go through with all the criteria again. So I'm having 1, -1, and 1 for the P. And then Q. What is Q? Q is actually 2, 1, and 3. Okay, so very obvious, P is not a multiple of Q. So it's not a multiple of Q. Okay, so now if it is not a multiple of Q, that means they are not same line, they are not parallel. So they should belong to either intersect to each other or either they are skewed lines. Okay, so to decide whether either intersect or skewed line, then what you need to do now is you need to let R1 equals to R2, right? Okay, so again, I'm using the column vector. R1 is 1 plus T. R2 is -1 minus T. R3 is, X is 1 plus T. Y is -1 minus T. And then the Z is 3 plus T. And you let it equals to R2. So R2 is 2 plus 2S. And then 4 plus S. And also the third one is 6 plus 3S. So 6 plus 3S. Okay, so you let R1 equals to R2. Okay, then according to the diagram, hope that you still have the idea. Okay, so according to the diagram here, you can see that what is next. After you let R1 equals to R2, of course, you need to find out the value of S and T. Okay, so now let's continue. To find out the value for S and T, right, you only need two equations because these are two unknown. Correct or not? So we are having three equations here. So it is more than enough for us, okay, to find out the value of S and T. Okay, so maybe for me, I will use the first one. Sorry, I will use the first one. Wait, okay, so maybe I will use the first equation and the second equation to solve for the value of S and also to solve for the value of T. Okay, all right, so now let us start. I'm having 1 plus T equals to 2 plus 2S. So you will get eventually T is equals to 1 plus 2S. So I will make this as first equation. Okay, then for the second one, I'm having negative 1 minus T, which is equals to 4 plus S. Okay, so I'm having T actually equals to negative 5 minus X. Correct. So I'm having negative 5 minus X. So this is my second equation. Okay, so I try to solve the simultaneous equation. So 1 plus 2S is equals to negative 5 minus S. So 3S is negative 6 and therefore your S equals to negative 2. So this is the value of S. Okay, right. So once you get the value of S already, for three-dimensional cases, you cannot just stop here. You need to continue to find out the T. So what's the value of T? So for value of T, it will be 1 plus 2 times negative 2. Then you have T equals to negative 3. So you need both answer, both S and T. All right. Okay, so once you get the value for S and T already, you still cannot decide whether are they intersect or skewed yet, right? So what are you going to refer is this one. Okay, so if you look at our question again, our diagram again, here they tell you, okay, is S and T consistent for all the component I, J, K? So how can we investigate or how can we check by using this criteria? What are you going to do with this one? Okay, is S and T consistent for all component I, J, K or not? All right, so now, just now you use equation number 1 and equation number 2 to get the S and T, right? So there's one more equation that you haven't used yet. So this is the third one. Okay, so to check whether the S and T are consistent for all, you have to use the equation that you didn't use just now. Okay, so I'm using green color to double check, all right? So I'm using the green color. Okay, so for green color part, left-hand side, okay, so the left-hand side of the equation, is 3 plus T. Correct? So 3 plus T means 3 minus 3. And you get a 0. And then the right-hand side of the equation, you are having 6 plus 3S. So 6 plus 3S is also 6 minus 6, which is equals to 0. So you can see that left-hand side is equals to right-hand side, which means the value of S and T is true or correct for all the three equations here. Okay, when you let R1 equals to R2. Okay, so what is the small conclusion that you can make here? You can say that S and T are consistent for all the I, J, and K. So when it is consistent for all the I, J, and K, you can make a conclusion here already, which is what? Which is R1 and R2 intersect. Okay, so once you know that they are intersecting each other, then goes further, what can you do? you can find out the angle between them and also the intersection point. So first, maybe I will show you the intersection point first. Okay, so for intersection point, again, I will write in a coordinate form usually. Okay, you can use any value, like either S also can, you want to use T also can. So for me, I'm using T. Okay, so 1 plus T. So 1 plus T means 1 minus 3 for X. And then for the Y is negative 1 minus T, so negative 1 plus 3. And then the third one is 3 minus 3. Okay, so what is your intersection point? It will be 2, 2, and 0. Okay, sorry, negative 2, 2, and 0. Oh, yeah. Okay, it's negative 2, 2, and 0. Wait, okay, so I'm having negative 2, 2, and also 0. So this is my intersection point. Okay, so besides the intersection point, you can also continue to find out the angle between the two vectors. All right, so maybe for here, I will just show you the steps, the how to start, and then you find out the answer for me. So this is my direction, the P, and this is my Q. Okay, equals to modulus P. Modulus P means 1 square plus negative 1 square plus 1 square. Q means 2 square plus 1 square plus 3 square, and then cos theta. All right, so if you continue from here, okay, try to get the theta. All right, so the theta for this case should be 51.9 degree. Okay, so please make sure that you attempt it on your own and see whether you can get 51.9 or not. So this part D, the example part D here, you can see very clearly that how we go through all the criteria to double check and see what case it belongs to. So it is actually intersect. So if let's say they are intersecting each other, then you can find the intersection point and also the angle between them. All right. Okay, so again, when you find out the value for S and T, then to determine whether S and T are consistent or not, then you have to use the third equation that you didn't use before. Then you double check, substitute the value and double check whether are they the same for the left hand and also the right hand side. So if they are the same, that means they are intersecting each other. If they are not the same, that means they are skewed, because that means the value S and T, right, only true for two equations. The third one is not true. So it is not intersecting, they are not intersecting. Alright, okay, so this is what I have for part D. Okay, I will proceed further to part E. Okay, so again, part E. So I will start from the beginning again. I will write out first. So what is the P in this case? So P is 1, 3, and 4. Okay, so what is Q? So Q is 4, negative 1, and 1. Alright, so very obvious that they are not a multiple of each other. So you can write P is not a multiple of Q. It's not a multiple of Q. Okay, so continue further. You need to let R1 equals to R2. What is your R1? So I'm having 1 plus T. Then I'm having 0 plus 3T. Then I'm having 1 plus 4T. Hopefully you know how to write out from the component IJK. Right? Then after that equals to R2. So R2 I'm having 2 plus 4S, 3 minus S, and also 0 plus S. Okay, so this is 0 plus 3T. Yeah, alright. So now you let R1 equals to R2, then you need to find out the value for S and also the value of T. So in my opinion, I find out that if I use the second and the third equation, it will make my steps much more easier. So I will write 3T is equals to 3 minus S. Therefore, S is equals to 3 minus 3T. So this is my first equation. Alright, and then for the second equation, I'm having 1 plus 4T equals to 0 plus s, which is s. So it is my second equation straight away. So 3 minus 3t equals to 1 plus 4t. So you should have 7t equals to 2. So your t is equals to 2 over 7. Alright, so if my t equals to 2 over 7, then I continue to calculate the s. S should be 15 over 7. Alright, so this is the value for s and t that you get already. Okay, so now for me, I'm using the second and the third equation. Alright, so this is the value that I get. Okay, alright, then now I need to double check, right? And see whether S and T are consistent for all the three components or not. So I need to use the first equation now. Okay, right, so I'm going to check left hand side. So for left hand side, I'm having 1 plus T. So 1 plus T means 1 plus 2 over 7. Therefore, I'm having 9 over 7. Okay, then for the right hand side, I'm having 2 plus 4S. So if I substitute the value s into the equation, I will get the value which is 74 over 7. So you double check these two values, left hand side and right hand side, are they having the same value or not? So they are not having the same value. So this is why we call it as not consistent. So that means value for s and t is true for the second and third equation because you use them to find out the value, but it is not true for the x component. Alright. So from here, you already know that they are skewed case. So you can make a simple conclusion that R1 and R2 are skewed. Okay, so this is what we mean by not consistent. Because if you substitute it into the third equation that we have, okay, then generally you won't see any how to say, you won't see that the value or maybe the value are the same for the left and the right hand side. Okay, so this is a skewed case. Okay, so before I proceed further, there's something that I want to let you know. For all the skewed case, if you use the second and the third equation to find the value of s and t, this is the answer, right? But if let's say just now you use equation number 1 and also equation number 2 to find the s and t, that means if let's say just now you use this and this to find the s and t, the value that you get is not the same for my answer. Will not be the same for my answer if let's say they are skewed case. Intersect case, then yes, no matter which two formula that you are using, the answer that we get is always the same. I mean from different person. If let's say you use the first and second one, maybe I'm using the second and third one. For intersect case, the value that we get should be the same for S and T. Okay, but if let's say for skewed case, if you are using the second and third equation to find S and T, the answer will be different from the one who used the first and the second equation to find the S and T. Okay, so it is a small detail that you should understand. So don't feel panic if let's say just now you use the first and second equation, but you didn't get my answer here. It is okay. Alright, so this answer is only meant for second and third equation. When you use the second and third equation to solve, then this is the answer that you get. Right? Because it eventually is a skewed case. Okay. Right, so after you decide that they are skewed case already, then you can still continue to get the angle. So some students will say, if let's say you are having skewed lines, how can you have the angle? Because they didn't intersect with each other. Alright, so you have to imagine that for these three-dimensional cases, right, when you are having the skewed case, to get the angle, actually you are looking from a certain point from the side. So that means skewed case, you can only see that they are skewed at a certain angle. Alright, but when you try to move your eyesight and then you look from the skewed lines from a particular side, then you can still see they have angle between them, although the lines are not touching. So like this one. Okay, let's say this is line number 1, and then let's say this is line number 2. But they are at different plane, right? Okay, but if let's say you see from this side, then you can still see the angle between them. It's very hard for me to draw it out here because I'm not good in drawing. Okay, but generally it is the angle that we see from one of the side. Okay, to view the skewed lines. Okay, Alright, so again, to get the angle between the two lines, the steps are still the same, where you use P, the direction of P, multiply with, dot the direction Q for -1 and 1 equals to the magnitude of P, which is 1 square plus 3 square plus 4 square. Q is 4 square plus -1 square plus 1 square, and then cos theta. Okay, so if you continue from here, again, they are asking for a cube angle. So if your dot product got negative value, you just change it, become positive straight away when you press for calculator. And then your final answer should be 76.6 degree. Alright. Okay, so this is how we actually apply and determine, okay, how we actually determine the pair of lines. What is the relationship between them? Right, so by looking at the diagram that I showed you earlier, so I hope that it will give you rough idea, okay, what are the criteria that you need to go through to decide all this. Okay, so I will stop here for this video, and then in the next video, we're going to discuss a few more examples on this part where they are asking for maybe angle and also the intersection point.